Hello. Next topic is recognition of reduction. This method is applied whenever we have to reduce vector element into a single element. For example, there may be number of reduction example. One is sum reduction. In sum reduction, whenever we want to do addition of all vector variable and we'd like to store that addition into a single variable, then that is known as sum reduction. And if array is given and you want to recognize the minimum value or maximum value of those array element, then that is known as min max reduction. Similarly, if you want to count array element, then that is known as count reduction. So example of sum reduction is given here. So basically reduction, you understood that reduction is if you are converting a vector element into a single element. If you are getting single element from a vector element, that is known as reduction. So this example is of sum reduction. As a single variable is initialized by 0 0.0, then we have a loop is running n number of times because size of the array or vector is n, and inside that loop you have a single statement s is equal to s plus a of I, where s is the variable which is defined, single variable, where we want addition of all elements of a. Okay, so in first iteration a of 1 would be added to s, in second iteration a of 2 would be added, and like this n iteration will add all n elements of array a in a single variable s. So at the end we'll get a single variable s which holds all value of a. So if you see this example, this loop is not directly vectorizable because it is having all three type of dependence. It is having true dependence, anti-dependence and output dependence on the same statement which is inside the loop. So it is not vectorizable directly. So here we would try to apply some method to vectorize it. If we assume that this summation is commutative and associative, then the previous program can be converted into this program, where the variable s is again defined by 0 0.0. That variable is same where we want the result, and then the single loop is divided into actually two loop, or you can say the nested loop. And here instead of adding all elements directly into a single variable s, we will use some intermediate variables, and partially we will take some elements from the vector and we will add that into different variables. And here number of different variables are 4 because my outer loop is going from 1 to 4, so there would be 4 different variables, and in this we will store summation of array element a, and then this intermediate result would be added into the final variable, single variable, which is s. So just look at this loop very carefully. The outer loop is do k is equal to 1 to 4 because we want 4 intermediate result. Then each of this, um, then inside that we have sum of k is equal to 0. So sum of k is representing intermediate variable. So since I have 4 different values of k, so I'll be having 4 different intermediate results: sum of 1, sum of 2, sum of 3 and sum of 4. So all would be initialized initially by 0 0.0. Then we'll enter into the inner loop, and inner loop having I is equal to k to n comma 4. So what does it mean? That inner loop starts with k, goes up to n in step of 4. So in first iteration of outer loop, value of k is equal to 1. So inner loop will start from 1, goes up to n in step of 4. Inside that you have statement sum of k is equal to sum of k plus a of I. So value of I will increase from k to n in step of 4. What does it mean? That inner loop is adding a of 1, a of 5, a of 9, a of 13 like this in step of 4, and summation of all this result would be kept in sum of 1. Then in second iteration, sum of 2 is calculated, where a of 2, a of 6, a of 8, a of 14 like this will be added into sum of 2. Similarly, sum of 3 is calculated, then sum of 4 is calculated. So 4 different values, intermediate values are calculated, which will have the partial addition of the array. Okay, then this after completion of this inner loop, then we have statement s is equal to s plus sum of k. So s is the variable where we want the final result, and sum of k holds sum of 1, sum of 2, sum of 3, sum of 4. This holds intermediate result. So meaning of this program and previous program is exactly same. We are adding all array element in two step. Previously we were adding all array element in a single step, and here we have added one more step, and that is intermediate result. So uh, instead of directly adding all element into variable s, we are first keeping in some intermediate variable and then finally into the variable s. Now with this transformation, what we will achieve is uh, here we can try to parallelize this loop, vectorize this loop partially, because complete vectorization is not possible. So first on this program we will apply the distribution. So if we apply loop distribution to this loop, you can clearly see that this outer loop is having three elements. First is initialization, which has sum of k is equal to 0.0. Second part is that inner loop, which actually calculate the intermediate values, and third is by using this intermediate value, final value is calculated. So these three parts are there. So we can distribute this outer loop into three parts. Okay, so after distribution, you can see that on right hand side that s is equal to 0.0, then the first loop which is going from 1 to 4, and it is doing only initialization to intermediate variable sum of k. So this loop is not having any dependence, so the first loop can be completely vectorized. Now first see the third loop. Third loop is do k is equal to 1 to 4, s is equal to s plus sum of k. So here the all three dependencies are there, so this cannot be vectorized at all. So third loop has to be executed in sequence. Now only remaining thing is the second loop, and second loop is a nested loop, so you cannot directly vectorize it because it is having dependence. So we'll first apply loop interchange into this. So if we apply loop interchange in this second loop, then after loop interchange we'll get this one in place of second loop. I becomes outer, k becomes inner, and inside that we'll have statement sum of k minus I plus 1 is equal to sum of k minus I plus 1 plus a of I. So here you can see that this inner loop is not having any dependence. Okay, so inner loop can be vectorized here. So after vectorization of inner loop, we will get the statement sum of 1 to 4 is equal to sum of 1 to 4 plus a of I to I plus 3. Outer loop cannot be vectorized, so outer loop has to be executed in sequence. So in this way, the loop which is not vectorizable can be partially vectorized. Okay, so we have distributed into three. First part completely vectorized, second part partially vectorized, only inner loop can be vectorized, outer loop cannot be vectorized, and third loop cannot be vectorized at all. So this type of methods are very helpful if you have the 4-stage pipelining. Now this recognition of reduction is having three properties which are reduce vector or array to one element. So this property was there in our example. It was the program was trying to reduce a vector element into single element S. Then this recognition of reduction can be applied if no use of intermediate values are there. So intermediate values should not be used in any other statement, then only you can apply this. Then reduction operates on vector and nothing else. So these are the three properties. And whenever a program is given, first thing is we have to see whether we can apply loop reduction or not. So it is very simple to find this out. We have to first see that in that loop there should be a presence of self, true, output and entry dependence. Okay, so inside the loop if you have a statement which is having all three types of dependence on the same statement is having self, loop, output and entry dependence. As you can see in the left side diagram, that it is having three types of self dependence, which are true dependence, output dependence and entry dependence. If this type of pattern is there in dependence graph, then you can apply recognition of string. On right hand side, if you see this example where in addition to s is equal to s plus a of I, you have one more statement t of I is equal to s. Here you cannot apply recognition of reduction because it is not following the second property which says that intermediate results cannot be used by other statement. So here intermediate result s is used by second statement. Also it is having a true dependence. Okay, so in addition to the self, true, output, entry dependence, it is having additional true dependence in the loop. So here you cannot apply recognition of string reduction.